image normalize image normalization, um, image annotation, augmentation, histogram equalization, and then we'll talk about how to blur image, how to sharpen image, how to increase the contrast. Then we'll do little edge detection, and then we'll just talk a little bit about contours, and that should end the class. And I pray that we should finish this thing today because each of them takes a lot of time to explain. All right. Okay. So I think we'll start with I think we already handled this. Okay, but if we didn't handle it, this is just changing color space of image from BGR to lab to huge saturation value. Huge saturation value means like we are trying to increase the huge and the saturation. We're trying to play around with the huge and the saturation value of the image. So um where's my BS code? Man. All right. Can I ask you guys one question? Okay. Oh, I already asked. So, we are still going to use the same image that we've been using. So we'll use this guy's image, but this is image is quite big though. So, new file is gonna we are gonna call it each saturation value.py. So we are gonna be doing. So import. Um, so let me explain before I get to code. I need to explain what is going on. So basically, the only thing we are doing is just that we are calling the image and then we passing the CV2 function. We increase with the saturation, we play around with the saturation value and also the um we're also going to try to see how we can do some other things with it. So it's very very simple. We have our image import CV2, um image is equals to CV2 dot mread, CV2 dot mread, and passing the image called image copy dot png, then cv2 dot show, let's say image, then amg, so we are showing, and then cv2 dot weight key 0, cv2 trying to set baseline, so we use it to work v2 dot destroy all windows. All right. So um so um python is p1. Okay, so that's good. So um let's first of all play with it a little bit. So the next thing I'm just going to do is the image shv, um mm, um going to be equal to cv2 dot cvt color, and then what are we passing? We're passing the image, then we're passing cv2 dot um color bgr bgr to. All right. Okay, so let's see that what that gives to us. Mm, okay. So um what we did here is just that we just played a little bit around with the saturation and the um what is it called, and the hue value. One sec. Let me, let me put this here so I can see. So we just played around with the saturation of the image, and also we can also try something like, we can also try this out. It's a bit too, but these are different image processing technique. You can just maybe when you have a free time, you can try to check them out. There are a lot of them out there. All right, and so for this very one, what we are doing here is that we are changing the color space. All right, so lab is actually like a C lab color space in OpenCV. What it does is just it separates the color information from the color sense intensity. So the lightness intensity, different spectrums, and the rest of some other things. But I don't think you would have a lot of applications where you may need to play around with things like this, except maybe if you are building things that's with like things that has to do with images, these scanned images, black white images, image from maybe this brain tumor scanning image. But most of the times, the things you are going to play around the most is going to be like the things I taught during the weekend, and then the things that has to be like um, normalization, augmentation, contrast, sharpness, and the rest of them. So, so segmentation. What we are doing here is basically we are performing color-based image segmentation using visual color space and technical color thresholding, likely using OpenCV. So um, basically, we are trying to tweak the different colors, the different pixel colors, trying to increase the threshold of the pixel, trying to reduce the threshold of the pixel, and basically so I had to write down this to explain to you guys. So in case you go through the slide, you would be able to read and understand what each line of the code does. So this today we have BGR threshold. We set a specific target for the color. It determines how much variation around this target, and then BGR, the minimum blue, green, red, right? So it calculates the lower and the upper bands of the specific color range, and the code is looking for any pixel where the blue channel is between what is between 100 and 140. And remember, this is blue, green, what blue, green, red. So what we do here is we are looking for anywhere where the code is, where the any place in the pixel where the channel is between 100 and 140, and 100 plus 140, that's in between the two. And similarity for the green and the red channel, the same thing. So now, and then also we mark the channel, we mark the blue, green, red. All right. So what we do here is that's in this place you see right here. All right. So this is the core segmentation step. The cv2.inRange function scans every pixel in the input image. If the pixel values fall within the defined minimum BGR and the maximum BGR, that pixel is maxed. If it doesn't fall in between these two values, then we mark it as zero. The image, and then we use this bitwise pixel to take the original image and then just max it, and then we get our result. So it's very, very simple. What did I say? We are basically trying to play around with the what? Uh, Left this slide. We're trying to play around with the image pixels, right? So we literally pick the pixel, the each of the pixel, the blue, green, red pixel, and then we find where the value is. We put a threshold, all right, and then we find where the pixel is in between 100 and 140, all right, and then after this, if the value doesn't fall between this particular mark, this particular threshold, what do? We just set the value to 0, and with that we are going to be able to do what? To segment the image. All right, so um let me let's test it out. So basically, so what do? This I've defined our image, then I can comment this out. So my BGR, my blue green red channel is going to be equals to what? Going to be equals to 100, 150. I'm going to set this, right? Threshold equals to 140. That's the max value I'm looking for. So what do? I find the minimum. If it is, I find the minimum by doing what? NumPy. So I need to import NumPy. Import NumPy. What do? NP dot array of what? BGR 0. So further, I pick the first pixel, all right, I minus it by the threshold, comma. I think if you were in our first class, you understand that right here we are trying to play around with the what? With the pixel. BGR. The third image, the third pixel, that's gonna be the based on we are working with non-PRS, and with non-PRS, what we are basically doing is that um, we are working with indexes, right? So this is going to be of index 0, it's going to be index 1, and this is going to be index 2. So now to get the maximum, to find which the maximum, to know if this is actually falling between our maximum value or between our lower value, that's what we are doing right here, right? So to get our maximum value, we do the same thing, np array, but what do we do this time around? We basically add it to find if this guy is actually close to what we want. It's as simple as that. And then after adding it, we max keep. So what does this max do again? Max BGR. This max BGR, what does it do? It literally goes through the is in range of what are we looking for? We have our image, and then if it is in range of minimum BGR and maximum BGR. Simple. So we mask it, and then we we get our results. So let's our result is gonna be equals to what? Now, mind you, at this point, we are trying to max our image between 0 and if it is in between the value, we max it to what? To 1. So The base operation we can do is use a bitwise operation to show our results. All right, so an open CV, bitwise operation. Why? Because we are doing a binary. We're working with binaries here, just zeros and ones. So open CV already has a function for that, right? And then what are we passing? We're passing in our image. We're passing in the mask. So our mask is going to be equals to what? Mask this, and that is all we need to do. Then we can show this. So where is it? So let me print this, and boom, simple as ABC. So um, that is that for segmentation, and then image normalization. This one is easy. So we are trying to normalize the image. We're trying to normalize the image, basically. So basically, what we are doing is that we are picking each of the pixel image, and then we try to improve, enhance the contrast, trying to normalize the variation and make the image normal and better. Simple. So, um, how do we do this with Python? First of all, I think I can. Okay, I can just leave this here for now. Um, I'll pick my image. So let's say my image is this right here. All right, and then I'll do like I'll first of all convert it to a float. All right, so um I'm gonna convert it to float 32. So I'll do um equals to image amg dot as type. Now mp float 32, and then I'll do cv2 dot normalization. Cv2 dot normalize. Whatever we're normalizing, I'm normalizing this image float, and then um we set the first match like value to 100, and then the alpha, we set the alpha to 100. So that's the alpha value. Sorry, let me try. Let me say I want to use 255 or 25. And let me just leave it at 255. And then I'm going to set the beta value to. So this is the alpha. This is the. What am I doing here? Oh yeah, this is meant to be none at first. Um, yeah, and then set the alpha value, set the beta value, and then what else do I do? I pass in the normalization type. This CV2 dot norm um, norm main mask. Okay, and then I can try to show this. Hmm. Img is equals to. Can try to show this and then see what this should give to us. Uh-huh. Okay, I think I'm gonna check if I get something bad then. let me clear this up. First of all, probabilities. Okay, let me reduce this a bit. So 10, okay, I think that was too much. Mm, 200 by 200. Mm, I think I'm getting a little bit of an error here. Let me check this. This is can see the image behind. Why is this so low? Wow. One sec. All right. Okay. So let me try to make this like 50. Let's see what would happen here. You can also like try to go and play around with the values. It gets better. Let me make this 200. Okay. Let me make this 10 and this 10. Everything gets worse. So you can as well like just what we're doing here basically is just that we are playing with the image pixels. I'm trying to normalize the image, making the image look better, play around with the image basically. Yes, let me see. I can make this 100. Okay. So now for this, I need to check this is meant to be. Yeah, am I reading the wrong values? Let me change the image to maybe this green red image and see what happens. J-red, the PNG, the normalized norm, IMG. Okay, can't see anything. Let me reduce everything. See if it's gonna give me what I'm looking for. Hmm. Basically, I just need to tweak this value until I get to where I want to get to. I try 100, 50. Interesting. But you can like tweak it and try to like play around with it until you basically get to like what you need, and it should give you the value you're looking for. Or you can as well just not convert it to float, um and rather just pass on your image as it is. Okay. um as simple as that. So we are literally trying to add noise to this image, the same image, but at least with some noise. All right. So let me explain what is happening here. So first of all, we generate a random noise using our noise value. So we use numpy array to generate a random noise. We pass in the noise um, factor. We pass in the size. The size is going to be the image, the shape of the image. All right, and then we return it. And after returning it, we just show it. So now this right here is going to more like add an image to what we already have, to our reference image, but now with the noise. And with that, we can just generate our image. So what is happening here is we pick our reference image, all right? We're generating another image, but it's going to be like our reference image with the noise that has been generated, the noise that we got. So basically what we did was we got an image and generated some noise on it, and then we are returning our image, but with what? With a noise. So it's very, very simple. So what are we doing here? Um, First off, we get our noise. Our noise gonna be equals to np dot random dot normal. Then we pass the scale. So the scale value. Our noise factor, I think I can choose like mm, 1.5. Or let me use 0.5, and then I pass in the reference image, which is gonna be the size. So my reference image was is image or image dot shape, and that's how we are able to get the shape of the image. And then we just do this as type what np dot int it. Um, and then what do we do? Our result image is gonna be equals to what? cv2 dot add. What are we adding? So we pick our reference image, which is our first image, AMG. And then we add the noise that we generated. The noise that we generated, and that's simple. So it's as simple as that. And all right, noise is crazy. It's noisy. Let me go back to our previous image that we have. Follow image copy.png. Please, if you guys are not hearing me, tell me how. Okay. So you see, we've added some little noise. You can look at this image. There's some noise on the image. Let me see if I can increase this to 1.5. Uh-huh. So I don't really know where you're gonna apply this, but there are some applications where you need to do some of these things. But these are simple image processing technique that you would need to simple image processing technique that you would need to be able to get to get a better algorithm, a better model. But there are sometimes you need to apply some of these things. All right. Um, and then histogram equalization. So histogram equalization in image processing technique. Um, what it basically does is it enhances the contrast by doing what it just stretches the intensity value of the pixel. Simple. So to do that is very simple. Just a few line of code. What do you do? We just, let's say we call it new image. We also save it to dot cbt color. Then we are passing in our image. Then we pass in cv2 dot color, what color, blue, green, red to what, to gray. So first of all, we basically convert our image to gray. All right, we basically convert our image to gray. Now why are we doing that? Because it just more like kind of try to distribute the pixel value of each gray, um, of the pixel value, so that each of our gray pixel would probably be like approximately the same, which is going to more like give us like more like a normal image, a normalized image, or more like a uniform histogram for our image. So we just like more like stretch the pixel of the image, and all we are trying to do is that we just make it, we try to make sure that each of them probably gets the same pixel and they are uniformed. So um so the equalized image is going to be what we pass the image that we converted. First of all, we haven't applied the equalization yet. All we've done basically is just to convert the image to grayscale, and this is where we apply the equalization. We just do cb2 dot equalization, equalize hist, and what are we passing? We are passing in the image, and then we can show this. This should give us something like this. And look, this is beautiful. so so you see, we've enhanced this image, we've made it look more better. This even looks more sharp than it was before. So let's say I want to show the image. Um, I want to show the image, img. So let me close this and run it again. So this is put it on intro. So these are our main image. All right, these are the images looking, and then this is the image that we equalize, that we just enhanced right now. More like you can see we've added some extra little nice cute lights here, and it's more like a little bit better. So these are some things you can do. You can use this to build some nice applications for things, manipulate image. Let's say someone is into photography, a lot of crazy things that you can do with all these things. All right, but one of the most fascinating and the most important, um, one of the most useful features, image manipulation technique that's always done in computer vision is always blurring image, sharpening the contrast, and the brightness. So how do you do this? First of all, we read our image, and to blur an image is very very simple. We call cv to the blur. You blur the image. You can use it this way, or you can use this other pattern where you call cv to the Gaussian blur. You pass in, these are going to be like your kernel values, like how you want it to be blurred. All right. And to sharpen the image, you just pass that blurred image here, and then you can sharpen it. But there's also some other ways you can do it by creating a kernel, and then once you create a kernel, you like increase the value of the middle pixel, and once you increase the value of the middle pixel, literally pass it across all the pixel of the image. Like let's say we have blue, green, red. Let's say we have blue, green, red. Increase the value of that middle pixel, and then you pass it across all the pixels. Increase the value of the middle color, for example. We pass it across all the pixels, and with that we can literally sharpen the image. Um, so and then also we can increase the contrast by just setting the alpha, the beta, and then we apply some transformation. We increase the contrast of the image. So how do we do this? Let's test it. You can later on you can go and play around with this in the house, and then you see how each of them work for you. So um, simple. What do we do? We to blur an image. Very simple. Blur equals to cv2 dot blur. Then you pass in the image we are blurring. The next thing you pass is your kernel size, right? So like this is the value that we are going to use to blur your image with, and then I'll just show this. Now, in the observe throughout this session, I've been trying to like use very layman, very like beginner friendly terms. So I'll not make things complicated for you guys. So, but let me increase this to like 15, 15, so you see the difference. Okay. Can you see? The image is barely getting blurred. 150 by 105 by 105. And then we'll blur the image. You can also use Gaussian blur. You can also use Gaussian blur. So you just cv2 dot Gaussian blur, and probably is the same thing. Just passing the image, the blur value, and then the sigma. You can just put like 10 here, and then you just basically play around with these things and see like how they change the different image function, how they change like how it works. All right. Now to sharpen the image, all we just do, we just pass this thing that we've got to. So we pass this, and then we just call a function called cv2.add weighted. Then we call the image that we have. Then we pass in this blood value that we got, this blood image, and then we put in. Now, more like what we are doing is that we are literally trying to pass in um, the alpha, all right? So I'm gonna set the alpha to like 1.5, and then um, this math line we can pass in the blood image that we have, all right? This blood, and then we set the beta, so I can like use minus 0.5, and then the gamma, set it to 0, and let's see what it does. Sharp. Okay. Boom. This is beautiful. Yeah. So you see what we've done to our image? We've literally sharpened the image. This is sharp. This is sharp. So now, mind you that we are playing around with the email kernel size here, with the blur value kernel, whatever thing. So let me reduce this and see what happens. Okay. Let me increase this to 255. So now, wow, this is clear. So now, where do you get to use all these things? Okay, let me increase this and see 2.5 by This is 0.2. And let's see what happens. Okay. Okay. So you see, we are trying to like increase the sharpness of the image, but the question now is, where do you get to use where do you get to use all these things, right? So you get to use all these things when, let's say for example, you are given a data set, and the data set of the image is not the data set you are given is not really clear. It's not clear to the point, to the extent you're looking for, or the data set is not sharp. So at that point, you need to like let's see 1.5. So at that point, you need to be able to apply some image processing technique to be able to sharpen the image. And these are things you can play around with. You need to be able to you need to pass the image processing technique. You need able to know which image processing technique to use to be able to give yourself a very very good a very very good data set, because if you don't have a good data set, you won't be able to train a good machine learning or a good computer vision model for image classification. So the number one most important step that is always done in everything is always data processing, right? And in this particular step, we have a lot of data processing technique, image processing technique we can apply. If you're using a model like TensorFlow, which we are going to cover in this tutorial, in this session, if you're using a model like TensorFlow to run image your computer vision model, by default, TensorFlow comes with all these things. So all you do is you just call TensorFlow dot augment whatever thing, and you just list everything you want to put in your value, and it will apply all the augmentation for you, which I'm gonna teach along the line, starting from next week or this weekend. Um, yeah, we still have enough time. So that is it. And one more thing, we can also like increase the contrast of our image. So let's say we have an image, we want to increase the contrast. All we do is just we call CV2, so I can say contrast to increase the contrast and the brightness, right? I just call my CV2, and then um, what do we do? We call convert scale. We call convert scale. All right. Then we pass in our image. We pass in the alpha. This alpha is going to control the brightness. We should set it from one to what to three. Then the beta is going to control. Sorry, this alpha is going to control the contrast. Then the beta is going to control the brightness, and then we can run it. So we just do our email CV2 dot convert um convert scale ABS. Then we pass in our image, we pass in our alpha. Our alpha, let's say I set it to 2. Or that's how much I want to control the brightness. Right, thanks. And then the beta, we're going to sorry, the alpha is the contrast, the beta is gonna be my brightness, set it to like 50 or 70. And then I can show this image. Yeah. That brightness was really, really nice. It's getting bright. It's brighter than the brightest. Okay. Um that's bad. Let me set it to like 10, and then reduce the contrast to, let's say, 1.5. Then I should get something good now. But you can as well go and play around with this value. Okay, it's beginning to see my guy. Let me see, I'll do 0.5. 1. Okay. So we can plan with these values and you see what you can do. So as you can see in that situation, what I did there was that I literally increased my brightness control too much. It was literally too much. So the more I increase this, let me see, let me increase it to like 3, the brighter the image gets. And these are things that you see in your phone cameras. You see you being able to increase brightness, playing with your cameras. Most of the times it is this image processing techniques that happen behind the scene. And as you can see now, I literally applying brightness all over this guy's face. Now these things are things that has been there since. Like it's not like they came up recently. These things have been there. That's why you hear like in the duration class we had, I told you guys that computer vision has been there from time on. It's just that recently as deep neural networks became a big deal, we AI started recently like getting heard and the rest of the things. So that is how you can play around with the brightness, contrast of your image. All right, and then what else is edge detection? So edge detection is very very important. It's beautiful. Edge detection literally has to do with like me getting an image and I'm looking for every edge in the image. I'm looking for edges in the image. So to run edge detection, the first most important thing we need to do is to convert the image to grayscale. Then after converting the image to grayscale, there are some um we can play with some edge detection algorithm. So there's subtle and there's canny. You can choose to use anyone. So um let me test some of them so you see. But basically, what I'm talking about is so I have an image like this and then edge detection. So I'm literally getting an image like this, and then I'm able to get the edges of the image. And these are very, very important in some pattern detection in images for neural networks. These are very, very important. You want to detect pattern of images, pattern of some. Let's say you have a very, very bad data set, and you know the only way you can get better images by running edge detection. As you can see, for example. So how do we do this? Simple. Um, First of all, we convert our image to grayscale. I think we already did that up here. Save it to gray. Oh, I deleted it, did I? Okay. Okay, yeah. So I need to convert my image to gray. So and then I'm going to pass that image to the blur function that we already did right here. So save it to the image blur. I'll reduce the value a little bit. Let me reduce the value to 4 by 4. And then I'll set this to 0. And I would apply my edge detection. So all I do is just edge is equals to what? Is equals to cv2 dot canny. So I'm going to apply this canny edge detection. Then I pass in my blur value, my blur which I got. Pass that here, blur. Then I choose my value. The threshold I want to say is 100. By the second threshold, maybe like 150. And I can show this. I can show this and I should be able to get the age in this guy's face. Okay. What's the error? Use the aggression blood image. What is this saying? Open CV. Okay. Let me check where I did something wrong. Can you guys hear me by the way? Can you guys hear
Yes.
me? All right. Okay. So let's say let me change this to 33, and then save it to the honey passing in my blood image 100. Let me change this to 200. Yeah, this should work. Okay. So you see, we're able to get the age in this guy's face. So I can play around with this now. Let me say I change this to 150. But basically, these are very, very important. Like this is a very, very, very important algorithm for some of the applications you want to build. Let me check if there's nice image. Okay, let's use this flower image. Let's use this flower image. I'm gonna change the image to save it to image.png. Then let's see. So we really see the effect. So you see. So this is simple, basic edge detection. All right. Um. Um. Let me try this. This. Um. This number. Let's say I choose like number 100 and this. All right. It even gets better. So I'm going to try this. I'm going to try this. I'm going to just pick one of these from this slide and see what this is going to give to us. Um, Lore. All right, so let me see what this is. All right, so you guys like you can go and play around with these things. I've dropped like a lot of things on the slide. You can play around with them, see how it works, see like what happens. You know, can literally like play around with these things and see what happens and see how they work and play around with them. All right. One last thing is contour detection. So contour detection is, let's say for example I'm given an image and I need to detect the contours of the image. So let me use a very, very good example. Normally there's what is called like if I want to differentiate, let's say I want to be able to detect an image of bird in the sky. I may not even need to use like let's say like to train detection model. I can just run contour detection that finds out detect the contours around the image and we are good. So let me show you guys an example. Let me show you an example of what I'm talking about, detection. So you see, I have this image. I'm trying to find like different points around the image. You see, normally I'm meant to perform like an object detection on this thing to find the contours, but I can just literally write a simple script and it can give me the result I'm looking for. I'm trying to check the difference so I can. So what difference between contour and edge detections in an image? So contour detection literally find individual points of sharp intensity change. Sorry, edge detection, while contour detection connects these points to form a complete image. So what do I mean? Let's say for example, in this image right now that we are. So if we look at this image, what are we doing here? Friends. In this image, there's sharp difference, and then we can point them out. And that's what we are printing here. But contour detection literally picks this thing and then does what? And join all of them together. It picks them and join all. the point together, and then with that we can get something that literally looks as if we are performing object detection, but basically just simple contour detection. So you can use this to do and play around with and like solve a lot of important things. All right, okay. So how do you do this? Let me explain the code before we get in. Simple. You first of all you convert the image to blue gray, which we already done. You set your threshold, all right, by using tv2 dot threshold. You set the threshold value, and then you now get your contours. So to get your contours, you pass in your threshold value, you pass in this cv function, cv2 dot read t3. Then you pass in another function here, which is going to get the chain, all right, and then you apply the image. You may not need to copy, you can just directly apply on the direct image, all right. And you pass in, what you do is like you draw your contours, you pass in the image. You may not need to copy once again. Pass in the image, you pass in the contours, that's the canvas of the image. You pass in the contours, then you pass in these values. All right. So first of all, from what you can see, you can detect that this is going to be the color. This is the type of line that we're going to use. This is going to be the size and this too. So we will check it out right now. So first of all, convert the image to grayscale, which we already done. Then the next thing is to get our threshold value. So this function used to produce literally two values, two results, returns to result, which is gonna be like we need to be able to store the threshold value, and that's why we are putting this. So we are not gonna use this right here. We can, you can put anything you want here. We're not using, what we're gonna use is this threshold value that's gonna be returned to us. To get that, we use cv2 dot threshold, and then we pass in what, our converted image, which is converted from grayscale. And then the first thing we do is to pass in the our threshold value, first threshold value, and the max, right? So the max is going to be 255, and then we call a function cv2 dot thresh binary. All right. Now why? Because why are we doing this? When we are playing with a grayscale image, which has to be like what, um we are trying to work with this in, we're trying to work with a grayscale image. Okay. So then we get our contours. That's what we are looking for. Our contours, and we can call this anything. We're not using this. Okay. So because of cv2 dot, want to find the contours around the image, we pass in the threshold value that we got, and we call this cv2 dot um red tr red t tree, and then we pass in our next cv2 function. We're going to be cv2 dot chain, right? Approximate, approximate. So now what else do we do? We just draw a contour. So new will be equal to what, cv2 dot draw contours, which should be drawn. Uh-huh. We pass in the our image, we pass in the contour. I spelled that word. I spelled that wrong. We see, oh, correct. Input X. Contours will be equal to what? Contours. and then um I'll put in my let's just need to move this. I'll put in my contour. I'll put -1 here, and then I'll put in the color. So the color is gonna be 0, 2, 5, 5. That's my blue, green, red. That's the color I want it to have. And then I put in the thickness. My thickness is 2. And then what else? The land type. Save it to dot line. Let's use this. So I think this should. So you see, so if I mesh copy, should be able to join all the contours around all the dots, be able to join them together. So this is useful when in like a lot of applications. So let me give you a very good example. A very good example. Let's say birds in the sky. Birds in the sky. So there are times you may not even need to like. There are some things you can just solve by just simple algorithms. Like what's the name of the image? Copy for. All right. Okay. So let's test with it, and you'll see how it's able to pick all those things, and then basically finds all the contours around the image, and then joins them together. With that, we've achieved a very simple object detector right there that can detect objects around in the place, or they may not be able to classify it. So I would like to give you guys one simple assignment using color spaces. You can use you can use color space to be able to check if an apple is ripe or not. You don't need to perform object detection. Just use different color space and try to perform. Let me add it to your okay. I'll add it to your weekend assignment. Use color space and try to perform to check if an orange is ripe or not. You can do it and drop it in the channel before everyone before I put in the task list. So this is the end of image image manipulation techniques. I think with this I've literally laid like some foundations for us so that when we are getting into AI, when we are talking about when we are trying to augment, annotate, when we are trying to like this is very important for everyone to know because if you don't know it, you are going to struggle in your computer vision career. Because there are times when data sets are not neat, data sets are very little. You need to be able to generate a lot of images. Like we've done a lot of things, for example, rotating. You can rotate an image and copy that image and save it, and that becomes a new data set. You can sharpen an image like I showed you, and that becomes a new data set. Now plus the old one, that's two. You keep the old one, you add the new one. That's two. I rotate like 90 degrees, 1, 2, 3, 4 times. That four image plus two, 6. I've increased one image to six different times, to six different data sets, right? I pick the same image, I apply I blur the image a little bit. That's six. Now why am I blurring the image? I'm blurring the image because when I'm training my convolutional neural networks, there's going to be a time where as I'm training my AI model, and then I get the model out. There'll be a time where a user comes to me and give my AI model an image of, let's say for example, image of a car that and data processing technique. If I'm given an image that rotation. I must have been able to give my AI model an image that is not clear, or an image that crop the image, crop, keep, apply color space, apply annotation, resize the image, blur the image, apply a whole lot of things, and one image becomes like 10 data sets. So let's assume you had like 10 image already. You If you apply that for each of them, you've already gotten 100 images. And this is what's going to help you to overcome overfitting in your AI model. The AI model doesn't overfit, and it doesn't underfit, it doesn't like mess up. Augmentation is always one of the most important technique to overcome overfitting. One of the most, whenever you just hear overfitting, one of the best things before you go into tweaking the algorithm, changing the parameters, changing the hyperparameters, changing the activation layer, whatever thing, the most important thing to look at first is your data set. Can you augment the data set? Can you generate extra? How can you reduce? How can you do this? Can you do that? These things, they are really, really important for us. So, and if you have any question, I think you can ask. Um, Kindly share slide link. Are there materials that we can? Yeah, yeah, yeah. I think each of the assignment that drop materials, but you can just go online and you check for image processing with OpenCV, so you can get your hands more stronger. Just check image processing with OpenCV. You will see it. Image processing, or just do OpenCV tutorial. OpenCV tutorial. You're going to learn a whole lot of things that I've not taught. Okay. Are you guys okay? What do you guys think? Do you have any question? I'm so sorry. I said the other day that I need people that are gonna help me, but I think some people will reach out to me, but I've never had time to reply to the messages. Is that bad? I'm really sorry, guys. It's 11 p.m. Yeah, I need to end the class. Does anyone have any question? Does anyone have any question? Can we extend this up? No, we can't extend submission. I dropped the assignment on Friday evening. Tuesday is a long day. It's a simple thing. Yeah, you had the entire weekend. Okay, I'll talk to IK about it. I don't know if it can be extended. Also, with the video be uploaded on YouTube, I think so. Yes, they have could come on the YouTube channel. All right. Thank you so much, guys, for joining today's session. Does anyone have any question? Can you raise your hand? If not, then I think I'm gonna end the class for now. Bye.